Hello, and welcome to Lesson 1 of the training module Second Life Batteries, developed by the SESA project. My name is Esther van Bergen from Sendex Nederland, where we focus on sustainable mobility. In this video, you will learn the basics of circular economy and applying its principles. We will start with what it is and why it's relevant, and then zoom in on the fundamental principles, how they can be applied relating to Second Life batteries, and what to consider. And lastly, we will discuss the value chain and the partners. The conventional concept of the economy is considered a linear economy. We take, make, use, and then dispose. It externalizes environmental and social factors and does not account for any related costs or benefits for that matter. A circular economy, on the other hand, is aimed at achieving economic development in a way that avoids unsustainable pressure on nature and people. It internalizes those factors at equal value. Or in other words, in a circular economy, waste and emissions do not exist and resources are infinitely reused in balance with nature and people. Making the transition to renewable energy is necessary to reduce the impact of climate change, for example. But we see that the resources needed, including those for batteries, still lead to unsustainable practices within a linear approach, such as mass-scale deforestation, pollution, and poor social and health conditions for employees or the surrounding communities. The principles of circular economy will give us tools to address this. The UN Agenda for Sustainable Development covers 17 overarching goals. Broadly speaking, the circular economy can contribute to all of the SDGs, but is most directly related to responsible consumption and production, industrial transformation, innovation and supporting infrastructure, and creating partnerships for the goals. These three goals can act as a flywheel for the other SDGs, such as life on land and in water, affordable and clean energy, decent work and economic growth, and so on. The diagram shown here gives a more detailed look of the concept of circular economy. And there are two main cycles. The biological cycle on the left, focusing on bio-based materials, and the technical cycle on the right, aimed at keeping products and materials in circulation. For the purpose of this module, we can mostly focus on the technical cycle, which shows the fundamental principles applied there. Another way to visualize these principles is through the so-called R ladder, where each step represents a principle and where the higher up the ladder is applied, the more mature the circularity of a product is, while the further down the ladder you start, the smaller the sphere of influence is. So let's zoom in a little bit more on the R's. We can roughly divide the ladder in three clusters. At this first stage, considerations are made for how the product is designed. Whether you just purchase or remake the battery system, the choices you make here influence the options in the other R steps. What are feasible actions or goals, and how these can be realized, your strategy. Once you have formulated these, you can focus on which criteria are important to adopt. Although there's not one simple checklist, there are common impact areas we can define. These are material selection, transport and packaging, remake, end of life, and added functional value. In each area there are different criteria you can consider for the stages where your redesign is translated into practice and how it is treated at end of life. So let's go over them in a bit more detail. For material selection, we focus on choosing the type of materials and treatments for the battery system, components, and the processes involved. Criteria can be using recycled materials, using recyclable materials, and choosing materials with an inherently low energy content. For transport and packaging, we look at how the battery components or materials are transported. Some criteria to consider here are using less non-polluting, reusable, biodegradable or compostable packaging for both purchasing the components and in supplying to your customers. We can think about how the transport takes place. Is it low or zero emission? Can the emissions be avoided based on the mode of transport selected? And can we minimize the transport distances? Are there local suppliers available? And where is your customer base going to be? In terms of remake, the considerations for material selections are also relevant here. But there are other aspects we can consider. Some of these are lowering the need for consumables, for example, for components that wear and tear or need retreatments over time. Focus on a modular design for easy access, repairs, upgrades and dismantling. Try to avoid waste at any stage and target low energy consumption for production, operation or at the end of life. You can also aim for a higher reliability of the product and its parts, so they last longer. At the same time, look for long-term availability of parts so that a product does not become obsolete just because a part is no longer available. At end of life, we aim for ensuring proper waste management. Some of the criteria to consider here are recovery of reusable parts, which can be used to repair batteries or to repurpose them for a different product, as well as recovering the materials through recycling, either for remaking batteries or for other products. If biodegradable and compostable materials are used, aim to recover those separately for a bio-waste treatment stream. And of course, avoiding risk of exposure to hazardous and toxic materials to both the environment and people has to have priority. And although preferably be avoided, safe incineration to recover energy in the form of heat and safe storage in landfill can also be criteria. Additional functional value is an area that deserves a separate mention. It focuses on how you can add value to a product in addition to its primary function. For example, by sharing the use of a product, by adding a function with extra value to the user of community, like reusing byproducts, and optimizing battery capacity by adding additional use of the battery. By adding performance sensors, it makes it possible for preventive maintenance, for example, which can avoid damage to components in batteries. And as a general criteria across all our areas, we can aim to work with local partners and for local customers to help stimulate the economic development, skills and job creation and community health benefits, etc. To reflect, there are a lot of things that can be considered and you cannot achieve all at once. There will be trade-offs between different criteria, or some of them will complement each other. Choose those that are the most important and feasible for your goals in the short term, and identify those that are better suited for the longer term. Before exploring the possible value chain, it is useful to highlight that circular economy relies largely on accepting shared responsibilities of what happens during the battery's lifespan. Circular economy thinks in creating value cycles instead of value chains, and where multiple parties cooperate to realize value retention and value creation. So who will be your partners? Here we have a variation of the technology cycle diagram from earlier. For the context of second life batteries, we can identify several different roles that may be needed at different steps, ranging from supplying materials, parts, and products to transporting from A to B and providing facilities or certain services or expertise. Mapping these roles can help you decide which you aim to adopt yourself and where you need or want partners. Then focus on the following questions. What supplies, additional services, and skills and knowledge is needed? What criteria have I set as requirements in relation to those needs for my goals? And who can provide this? Some roles will be relevant to multiple steps, for example, as is visualized here. Various types of distribution or collection services are needed at different occasions. In practice, it is possible that some of these roles are provided by the same partner, like here for transport purposes. Although some transport-specific expertise may be required, for example, when collecting batteries or components when it's classified as waste, like here. Possible legislation and industry standards may have specific criteria, and not all transport partners can provide these. Other roles can be very R-specific, related to actions. For example, a designer who designs the energy storage system according to the goals and criteria you set out, or a person who performs maintenance and repairs on site for the customer. When developing your circular value proposition, consider that a successful model makes clear what a value partner brings to the proposition and what a value partner receives from the proposition. And remember, this value can be economic, environmental, and social in nature, or a combination. To wrap up lesson 1, here's a brief summary. You can also find additional information and links in the material provided. Thank you very much for your attention. I hope you found this lesson useful for any future endeavors, as well as the remaining lessons in this module.